Hello and welcome to the first of two videos on subsetting R objects. Now this might seem like a lot of time to devote to the topic of subsetting vectors, matrices, arrays, lists, and data frames. However, in Hadley Wickham's book, Advanced R, he devotes an entire chapter to the topic, and I tend to agree that this is a very important topic that requires quite a bit of time devoted to it because R is a very powerful subsetting framework, and there's lots of different ways to do it. And you'll really become a master R programmer if you can understand all the different ways of subsetting and which one to choose in each situation. So with that, let's get started. The first video will just be about atomic objects. That includes atomic vectors, matrices, and arrays. And then the next one will be about lists and data frames. Okay, let's create an example to work with. I'm going to create the vector A, which is the square of the integers 1, 4, 9, 16. So we'll create that and print it out. Now, if you remember from a previous video, this is actually not an integer vector. You can see that it's a double vector when you do type of. Now, here's a simple way to subset. If you want to grab the third element of A and return it, all you need to do is type A square bracket 3, and that will return the third element. So important that you're using square brackets, not round brackets. And you're just giving what's called the index or the position of which element you want to extract. So this should return 9. You can give it multiple indices, but if you do it this way, it will give you an error. That's because when you want to extract multiple indices from an atomic vector, you have to give it a single object, itself an atomic vector, which contains the indices that you want to grab. So this will grab the third and fourth element of A, 9 and 16. You can put these in whatever order you like, but the subsetting will respect the order that you give it. So this gives 16, 9. And you can repeat indices. So if I do this, you could probably guess what will happen, but this will return the first element twice, then the second element twice, then the third element. So this gives 1, 1, 4, 4, 9. Another handy thing is that if you want to return A but with some indices removed, you can specify the indices that you want to remove with their negative values. So if I want to get everything but the second index, I'll type A of minus 2. So that gives 1, 9, 16, omitting the 4. And you can put these together. So you can, if you want to omit the first two elements, you do that. Oh, I didn't do a minus. And that actually foreshadows what I want to tell you next. So you can't tell it to say, oh, minus 1, 2, which would mean, I don't know what that would mean. Omit the first one, but give the second one. Well, then why wouldn't you just say give the second one? This doesn't make a lot of sense. So predictably, R gives you an error in this situation. So you can't mix up negative indices, which means leaving out, and positive indices, which means keeping in. If you try to give R an index that's actually not part of the vector, so this is a vector of length 4. So if I try to grab the 6th index, it gives you an NA. So importantly, this does not throw a warning or an error. So this can be another source of silent bugs. So something when you're writing your code, you may want to check is if you specify an index, you may want to check that is actually that index exists in the vector. Okay, and then you can also specify NAs. So if you do that, you get that. If you do this, this gives the third element and then an NA. If you have a named atomic vector, you can subset using either the positions or the indices or the names. So let me create an atomic vector here, a named atomic vector. Okay, so that's B. We can use indices to extract. So this will extract E. Importantly, it keeps the name. Or you can use the string of the name. So this will extract the element whose name is E. And you can put these together in an atomic character vector. Okay. Let's see. Let's look at an example. Okay, this will be an interesting one. So let's do pi 3. Now this is a situation where I want you to think about, I want you to be typing these in as we go, but I want you to think about what will happen here given the rules that we've learned so far. So I'll give you a hint. What happens here is this gets evaluated first, and then it gets input as the subsetter of B. So take a minute and think about what you think will happen. And then run it. And you get an NA there. So why does that happen? Well, let's break this apart into pieces. So what happens when you evaluate this, it becomes the character vector pi 3, where 3 is a character object, not an integer or double index. So it puts this in as a subsetter, and the character 3 is not the same thing as the integer or the double 3. And so what it's doing is it's looking for a named element called 3, which is perfectly, well, is that allowable? Let's check that. Well, the point is that there is no named element called 3, so it doesn't work. Let's actually see if this does work. I've never tried this. That actually does work. So if you do, let's go over here, names of B, you get that. Now I'm curious. So this is what you should be doing. As you're writing the code, you may be curiosities that come up. This happens to me as well. I'm always learning new things about R. My curiosity is, what happens if you do this? No, it doesn't like that. So it expects either letters as the names, but it doesn't like, and it can deal with a character. So this works. So importantly, that is the third element, but that is the element whose name is 3. Okay, those are two different things. But it can't do this. It doesn't know what to do with that. Okay, so that's kind of interesting. I'm going to leave this in here. What happens here? Does this do the same thing? Yeah, that's the same thing. So you can give these as character strings, or if they're just letters, you can give them without the character strings. R knows how to interpret that. All right, so that's using numbers or names to subset things. We can also use logical vectors to subset objects, and this is really powerful. So let's create a logical vector. So this is the logical vector b greater than 4. So what's going to happen here is it's going to look at all of the elements of b. It's going to compare each of them to the number 4, and it's going to return true if the element's bigger than 4, and it's going to do false otherwise. So the first element is, so this should say false, false, true, false. So let's run that. Very good. And then we can use this to subset B's, and this comes in handy a lot. So if you wanted to extract all of the elements of B, whose value is greater than 4, you do it this way. It's a very small piece of code that does it very easily. So that just gives the element tau, whose value is 2 times pi, or 6.28. You can also type them in. So if you do this, this gives all of them. So I think what happens here is similar to up here. Didn't quite know what to do with that, so it just repeated it 4 times or recycled it. Here it's recycling the value true 4 times. If you do this, it's going to recycle true false twice, because that will fill up the 4 elements. So you get true false, which gives you E and tau. Let's do it 3 times to see what kind of, if it gives a warning. Nope, that's no problem. It gave the first element, not the second element. Okay, that's very interesting. I don't recommend doing this because this is kind of, I'm a seasoned R programmer and I didn't know what this would return. Therefore, if you try to show this piece of code to someone else, it's really going to confuse them. So don't do this. So in general, you want to, when you're using logical vectors to subset a vector, the logical vector should ideally be the same length as the original vector. So here's a case where the logical vector false, false, true, false is the same length as the original vector, which is this one. And what it will do predictably, it will grab the ones that are true and it will leave out the ones that are false. So try to avoid doing things like on these 3 lines. Now there's a really handy function called which converts a logical vector to its integer version. So if I do, so b greater than 4 looks like this. If I say which, it will give me the indices for which the vector is true. So this returns a 3. And then you can subset using that. So which b greater than 4 should, you think about the order of operations, it's going to evaluate this first. So that's false, false, true, false. It will apply which to that, which will return the index of the trues, which is only 3. So this will become 3. And then it'll do b of 3, and it will pull out tau. Okay, so this is 2 different ways of doing the same thing. So why do it both ways? Let's see, I got these in the wrong spot. So let me move this. These are 2 different ways of doing the same thing. So what's the difference? Well, there actually is a subtle difference. If the original thing, the logical, contains any missing values, it will pipe those missing values into the subsetting. However, if there are missing values, if you apply which to them, which will not grab the missing values, and so it will not give you missing values in the return. So let's just look at an example to see how that works. So I'm going to create a new vector b where I take b and just append a missing value. So that's b. It's not named, but that's okay. So if I do b greater than 4, it gives false, false, true, false, NA. And then if I do b of b greater than 4, well, it's going to grab the tau, because that's a true, but then it's going to return NA for the last one. Okay, so that may be what you want the code to do. So if your data has missing values and you want to know about them when you're subsetting them, then you should do it this way. However, if you just want to grab all of the values that meet the condition and ignore the missing values, you'll pass it through which first. So let me run this. That just gives the tau, so this should just give tau 6.28. Okay, so that's subsetting for atomic vectors. There's a few different ways to do it. You can use type in the indices that you want to grab. If it's a named vector, you can give it the names. And you can also do logical subsetting, and you can convert the logical values back to integers or indices with the which function. Okay, let's dive into matrices. So matrices differ from regular old atomic vectors because they have a dim attribute to give the dimensions of the matrix, and they're two-dimensional objects. So subsetting works a little bit differently, but it inherits some of the properties of atomic vectors. So let's create a matrix to work with. There's lots of different ways to create matrices in R. I'm going to use a function called outer. I'll show you how this works. Okay, let me create the matrix and then we'll look at it so I can show you what happens here. Okay, so the way outer works is it does an outer operation. So you probably heard of outer product of two vectors. Here this is doing an outer addition of two vectors. So it takes the vector 1 through 4, and then it does the outer addition of the vector 0.01, 0.02, 0.03. So this first element is 1 plus 0.01, and then it's 1, 2, 3, 4 plus 1.01. This is 1, 2, 3, 4 plus 0.02. This is 1, 2, 3, 4 plus 0.03. So if you didn't get those details, that's fine. Look at the documentation of outer to see exactly what it does. And then just take this as, okay, this is the matrix we're going to work with. Okay. Now, the most common way you'll see to subset matrices is to specify the row and the column that you want to grab. So if I want to grab the element in the first row, second column, then I do it this way. Square bracket, I give the row that I want, separated by a comma, and the column that I want. Now you don't do it this way. This will give something different. We'll see in a second. You do it this way. So this gives 1.02. That's first row, second column. You can specify multiple rows or columns. So if I want the first 2 rows and second column, I do this. So this gives 1.02, so first row, second row of the second column, 1.02, 2.02. And you can do as many as you want. So you want the first 3, you grab that. You can specify, like if you want to extract a rectangular subset, you can do both rows, give it a vector for both the rows and the columns. So this is going to grab everything that's in both the first 3 rows and columns 2 and 3. So it should grab these objects here. And then there's a shortcut. If you want to grab everything in either a row or a column, you'll leave it blank. So if you do m, comma 2, this will grab all of the data in the second column. And M4, comma, will grab all of the data in the 4th row. Okay, so that's grabbed those numbers here. Now, it's very important, and the source, another source of silent bugs, that you be vigilant about the fact that if you extract something that can be converted to a vector, it will convert it to a vector. So when we grabbed everything in the second column, what it returned was not a 4x1 matrix, but a length 4 atomic vector. It did the same thing up here. Here it did not, because there was no way for it to convert this rectangular object back to a vector. So it kept this as a matrix, but everything else it converted to a vector. This can be a source of silent bugs, because if your code expects, so like, okay, let me give you an example. So if you do, let's say n equals the second column of m, and then we'll print out n. And then if you're thinking that this is a matrix, you might try to subset it like this. I want the first, the third element in the first column. It gives you an error here because n is not a matrix, so you can't subset it in that way. Okay, now if you want to force R to keep it as a matrix, even if it can convert it to a vector, there is a way to do that. So here you would say you include an additional comma and say drop equals false. So this keeps it as a vector and as a matrix. And let's verify that. We could say n third one in the first column. That should work. Okay. And then the same thing here. If we want the first, everything in the fourth row, I have to do a comma after this one. So the space here indicates that I'm grabbing everything from the fourth row. And then I do drop equals false. Okay, so you can see by the way it gets printed out that this is still a matrix. Okay. As we learned in a previous video, matrix really is a vector with a dim attribute. And R uses that to allow you to subset that matrix as if it were a vector. So let's print out M once more. And by default, R uses column major ordering. So if we're thinking of this as a vector, the elements are numbered 1, 2, 3, 4, if you can see my cursor, 5, 6, 7, 8, then we jump back up, 9, 10, 11, 12. So if I want to grab the fifth element, it's going to grab this one here. And then you can put these together in a vector. So this should grab this element. The sixth one is here, and the 11th one is there. You can also use negative indexes, but let's think about what's going to happen here. Does it make sense to have a matrix but one of the elements is removed? It maybe could put a NA in there or something, but it doesn't try to do that. It just converts it back to a vector. So you see it left out, it ordered them column major order, but it left out the value 2.01. Okay, so this does work. You probably won't see this happen too often in code that you subset a matrix like that, but it does work. You can also use logical subsetting. So this will return a matrix. And then you can grab all the values for which they're true. This again, it won't make sense to keep this as a matrix because you can imagine the trues and false could be like spread out randomly. So this returns a vector. You can also do which. So let's look at it this way. Which m greater than 4. So what this does is which is thinking of this object, even though it's displayed as a matrix here, as a vector, and is telling you which index in the column major order they're greater than 4. So it does, this is the 4th one, that's the 8th one, that's the 12th one. So I can do, this will work just fine, and it'll give the same answer. Just these 3 values. All right, there's another slightly less well-known way to subset matrices, but this is actually pretty powerful, and I've seen use cases for this. So you can actually give it, inside the square brackets, a matrix which has row-column pairs. So let me create one for you so you can see what this looks like. So I'm going to say m greater than 4, and which has an optional argument called r.end, array.end, whose default value is false. Actually, let's set it to false first. So this does what it did before. But if I set this to true, so this is returning 4th, 8th, 12th. If I set this to true, what it returns are the positions, row and column, of the original matrix M, let me print that out, for which the condition is true. So this means in row 4, column 1, it's true. Row 4, column 2, it's true. And row 4, column 3, it's true. And nowhere else. Now you can use this to subset the matrix. So if I say M of this thing, and notice that there's no, so this is a single object. It's printed here. There's no commas here. This is just M of that object. And let's make that more explicit. So let's just do this. Okay, now you can see that this is just an object, single object, and we can subset using that object. So that grabs these values. So these are the values whose positions are 4, 1, 4, 2, and 4, 3 in that order. Okay. Now let's do this next example, because I think if you really understand this example, you'll be well on your way to really understanding how things like automatic coercion from a matrix to a vector work, so on and so forth. So first thing I'm going to do is let's just type the whole thing out. Which m greater than 4. Let's actually not type it out since we've made it into an object. So MWW we just did. And what I'm going to do is grab the second row of that. So let's give ourselves some room. There's M, there's WW. And let's think about this line here. So what is going to happen here? Think about that for a second. You might think it's going to grab this element because it's taking this out. And as we just learned, if you subset it that way, you get this element. However, it doesn't. It gives you this element and then this element. So take a second to think about why it did that. The reason is that this operation automatically coerces the result to be a vector. And then if you give a matrix a vector of indices, it will treat the matrix as an atomic vector and grab those indices in column major ordering. So if you do this, it gives 4, 2 as an atomic vector. That is the fourth element in column major ordering, and that is the second element. So it returns those two values. So let me just run that again. Okay. Now, okay, why is this? So if we do class, that's an integer vector. To prevent this, if you really wanted to do this, you would do which ww2 drop equals false. And I wouldn't do which, I would say m. M of ww2 drop equals false. This is a matrix, as you can see. It's a 1 by 2 matrix. And this will rightly grab this element, row 4, column 2. Okay, and that's because this remains a matrix. As we learned before, R has support for multi-dimensional arrays. So let's just create one. If you remember, there's an object in R called letters. By the way, if you do capital letters, they're capitals. So I'm going to take those first 12 letters and put them in an array. So A, R, R, use the array function. You give it the data that you want to put in there. And array function differs from the matrix function. So, all right, let's just look at this real quick. If we're using matrix and you want to specify the rows and columns, you specify them separated by commas. So this will create a matrix with 4 rows and 3 columns. And there's no errors or warnings that get displayed because 4 times 3 is 12, so everything works out. Now, array works a little bit differently, that you specify the dimensions in a single vector, in a single argument. So if I want to have 2 rows, 3 columns, and 2 slices in the third dimension, you do this. And again, no warnings or errors because 2 times 3 times 2 is also 12. Okay, so this is separated into, you can think of this as like two 2 by 3 matrices front and back together. Okay, so indexing works very similar to matrix. If you want the second element from the first dimension, the first element from the second dimension, and the second from the third dimension, it's going to grab, I like to kind of read this backwards because, okay, so this means, that 2 means we're going to be working with this part of the object. And then it's the second row, first column. So this should return H if I'm remembering this correctly. Yep. And then you can also do with a single index. So this will grab the 5th element in sort of column major ordering. So it's within each of these, it's column major. So it's 1, 2, 3, 4, 5, 6. And then you go to the next slice, 7, 8, 9, 10, 11, 12. So this should return E. And if we do 7, it should return G. Okay, good. One thing to remember as we're working with this, we just saw this one. This is different from this. So they differ in that we're giving 3 separate objects separated by commas as opposed to a single object, which is an atomic vector. So this will return H. This will return the second element of array of ARR followed by the first element followed by the second element. So it should return BAB. Okay. All right, you can also do this row column pair, but of course you'll need a third element in the matrix. So let's make one here. Ins matrix okay, so we can give ins inside of here. This will work the same way we did row column pair subsetting of matrices. So this is going to grab the 2, 1, 2 element. And then we can actually put these together. So if we want to do more of them. So 2, 1, 2. And then you want, let's say, 2, 3, 1. Now it's going to have 2 rows, 3 columns. So this represents the element in row 2, column 1, slice 2. This is the element in row 2, column 3, slice 1. And let's print this out. So what this should return is 2, 1, 2, H for the first one. And then 2, 3, 1 should be, 2, 3, 1 should be F. So this should return HF. Yep, and that's what it does return. Okay, so with arrays, you can either give it the indices separated by commas, and here also you can do a vector of indices. This will give more than one. And you can also give it atomic vector. This will extract them in the array version of column major ordering. And then you can also do it with row column slice triplets as well. Now you can also do assignment to subsets of objects. So this is going to work similarly to how we talked about replacement functions. When you did a replacement function like names, you can use that function to extract the names of the object, or you can use it to set the names of the object. And it will work the same way for subsetting vectors, matrices, and arrays. So let's recreate our vector. So that's A. And let's go ahead and make our named vector as well. Okay, so that's A and B. We can do things like this. So B of 4 is A of 1. So what's going to happen on this line? It'll evaluate the right-hand side first. So this will extract the first element of A, which is 1. And then it will assign it to the fourth element of B, which is currently NA. So if I do this, I should get that. Now you can combine this with replacement functions. So this is kind of interesting. So right now, this element doesn't have a name. If I wanted to name just that element, I can say names B first element is 1. Did I run that? That actually doesn't work. Oh, that's because I named the wrong one. Okay, let's start over. I want to name the fourth element. Okay, so that's B. Name the fourth element 1, and that works. So what I did wrong is I renamed the first one instead of the fourth one. Okay, so you can, this is a really interesting line because it's using both replacement functions and subsetting assignment in the same line. Okay, now things can go right or wrong if you try to assign multiple things. So here's a case where it's going to take the second element of A, which is 4, and it's going to try to assign it to the first 3 elements of B. This is going to work okay because it can recycle that one element that I've highlighted 3 times to assign it to B. So let me run this. So it took that value 4, recycled it, and assigned it to those 3 things. Now, if you try to do something like this, so what we're doing here is we're extracting elements 4, 3 from A, so that's 16, 9, and trying to assign it to the fourth element of B. And here it complains because the number of items to replace, which is one thing, fourth element, is not a multiple of the replacement length, which is 2 here. So it didn't give an error, it gave a warning. If we look at B, it actually did assign the value 16 to the fourth element of B. So what it did is it took the first element of this, which is 16, and assigned it to here and ignored the second element, but also returned a warning to say, hey, this is probably not what you intended to do. You can also do this. This kind of thing I don't really recommend using in practice, but so here we're extracting the first two elements of A, which are 1, 4, and assigning it to the first 4 elements of B, well, which is the entire thing. I think this will not throw a warning. That's because the number of items to replace, 4, is a multiple of the replacement length, 2, and so everything works fine without a warning. If we look at B, it did 1, 4, 1, 4. So it took 1, 4 and recycled it twice to fill out the length 4 vector. Now, I don't recommend doing this very often because this is kind of confusing and it may not be so readable. You can also leave this empty. This will assign 0 everywhere. That is importantly different from this, which will assign the value 0 to the object B, which will overwrite B and just create a new object that's length 1. Okay, so if you want to replace every value with something, you have to put the empty square brackets. If you want to overwrite the entire object with something new, then you don't do the square brackets. Okay, on to matrices. Things will work similarly, but there's obviously difference because it's a two-dimensional object. Okay, this is the same matrix we've been working with. If you want to make an assignment to a single value, so if I want to make the value in row 4, column 3 something else, I just do that. You can see it shows up here. You can also treat it as a vector. So if you want to make the 9th element something else, that will change. This is the 9th one. And then you can also give it row column pairs. M All right, so let's take a second and parse this. So the data is 3, 3. And I'm going to put it in a 1 by 2 matrix. So if I run this, it's that. If I were to run this, it would grab that value. That's this one here, 3, 3. And I can also do assignment. So if I want to make that something else like -1, it does assignment there. Okay. And you can also do logical subsetting. So let's take a look at M. So we could say M of M less than 2 is NA. It will take the elements whose value is less than 2 and set them to NA. Okay, so you can use logical subsetting as well. All right, lastly, on to arrays. Let's create our test array. made a typo there. Okay, that's our test array. You could do assignment if you want to change a single element. Do that. You can also treat it as an atomic vector, make the 5th element something else. That will work. So that is the 5th element. And then if you want to change all of them, this works for matrices too. We didn't show it, but if you want to change all of them, but keep it as a 2 by 3 by 2 array, you do square brackets with nothing in there. Okay. Okay, so that is subsetting for atomic objects, vectors, matrices, and arrays. There's various ways to do it. It's important to master, in particular, logical subsetting, because that's how you extract data that meets certain criteria. And then you can also do assignment to subsets of these objects. Okay, next up, we're going to do subsetting for lists and data frames, which works a little bit differently. So we'll see you then.